Let's move on to question number 9. Question number 9 is about electric circuit and electrical quantities. 40 lamps, each of resistance 8 ohm, are connected in series to a 240 volt supply in order to decorate a tree. 9a. Calculate AI, the current in each lamp. The total resistance of 40 lamps connected in series is the sum of all resistances. So, the total resistance equals to 40 times 8, which equals to 320 ohm. When resistors are connected in series, the current inside each resistor equals to the total current inside the circuit. Use the equation V equals to I times R. So 240 equals to I times 320. So I equals to 240 divided by 320, which equals to 0.75 ampere. So the current in each lamp equals to 0.75 ampere. 9a double I. The power dissipated in each lamp. Power dissipated equals to I squared times R. So, power dissipated equals to 0.75 squared times 8, which equals to 6 watt. So, the power dissipated in each lamp equals to 6 watt. Question 9b. The lamps are designed to fail short. If a filament fails, the lamp shorts so that it has no resistance. The other lamps continue to light and the current increases. The lamps are connected through a fuse that blows when the current rises above 0.9 ampere. At this current, the resistance of each lamp is 5% greater than its normal working resistance. Calculate the maximum number of lamps that can fail before the fuse blows. First, calculate the resistance of each lamp when the current rises. In the problem, it is said that the resistance will be 5% greater than its normal working resistance when the current rises. Then, the resistance will become 1.05 times 8. 1.05 comes from 1 plus 5%. 8 is the resistance of each lamp before the current rises. This equals to 8.4 ohm. Next, calculate the voltage consumed by each lamp after the current and the resistance increase. Use the equation V equals to I times R. So V equals to the I becomes 0.9 after the current increases times 8.4, the new resistance. This becomes 7.56 volt. Now let's calculate how many lamps can be lit by the 240 volt supply. The total supply is 240 equals to the voltage consumed by each lamp, which is 7.56 times the number of lamps which can be lit. So, the number of lamps which can be lit equals to 240 divided by 7.56, which equals to 31.7. Round this off into 32 lamps. Then the maximum number of lamps that can fail before the fuse blows is, the total lamp is 40 minus 32 lamps here. The number of lamps which can still be lit by 240 volt supply after the current and the resistance increase. 40 minus 32 equals to 8 lamps. So, the maximum number of lamps that can fail before the fuse blows is 8 lamps.